In this module, we will continue to explore the 4 stages of selecting a motor by looking at the next 2 factors in the equation: infrastructure and standards. Network voltage and frequency vary around the world. Also, industries and applications may require voltages that are unrelated to the country where the motor is used or purchased. The ability of the local electrical network to support the application is of particular importance when starting the motor. For fixed-speed motors, an excessively long starting period will cause harmful temperature rises, and the high currents can cause electromechanical stress. The starting time is a function of load torque, inertia, and motor torque. Between starting speed and nominal speed, it must be ensured that even under unfavorable conditions, such as low voltage on motor terminals, the motor torque is always sufficiently high to cope with the highest possible load torque. Electric motors produce a lot of starting torque and can generally cope with a long start caused by a load with a lot of inertia, such as a fan or a pump starting with the valve open, where the impeller has to push against the full body of liquid straight away. This higher torque requires more electrical supply current, so care must be taken to ensure that the local infrastructure can support these current peaks. Often, network restrictions on starting current will influence the specification of large motors. The growing practice of using smaller induction motors with variable speed drives is increasing the amount of reactive power taken from the network. This is something to consider when selecting the motor, since users taking too much reactive power are liable to fines. A synchronous motor can be made to both generate and to consume reactive power by adjusting the excitation. An induction motor only consumes reactive power. An alternative to using a synchronous motor to produce reactive power is to install synchronous compensators in the internal network. Static capacitors can also be used. So now we know the requirements of the application, the torque, speed, power, and electrical characteristics of the motor we want. We can narrow down our selection by turning to the international standards that govern the dimensions, efficiency, and performance of electric motors. The main international standards are IEC, the International Electrotechnical Commission, and NEMA, the National Electrical Manufacturers Association. However, in addition to the main standards, there can be national or industry-specific standards and even customer specifications that affect the motor selection. Make sure you follow all applicable standards and specifications for your project. As we discovered in the module covering motor efficiency, the motor might also be subject to MEPS, setting mandatory minimum efficiency levels. In the next module, we will look at where the motor will be used and how that affects selection.